Alright, geometry class, it's me, your geometry teacher, Mrs. Norton, and I have prepared a short video, a slide video for you today, and that we're going to be talking about Chapter 1, Section 2. It's measuring and constructing segments, and here are our objectives. We're going to be using length and midpoint of segments and constructing midpoints and congruent segments. Well, we're not going to quite get to the constructing midpoints and congruent segments. I'm going to tell you in your book where you can find that, and we can cover that in class later. So here we go. So first thing on your paper is this right here. We have the distance between 2 points is the absolute value of the difference of coordinates. So we've learned this before, the absolute value, in a previous algebra class. And that means whenever you take the absolute value of something, if it's negative, it becomes positive. If it's positive, it stays positive. Okay? So if the coordinates of points A and B are A and B, down here, it's referring to this right here, then the distance between A and B are A minus B or B minus A. And the distance between A and B is also called the length of AB, segment AB, or just AB. It is equal to AB. Here we go as an example. We're asked to find the length of each of these. So find the length of BC, and when we do that, we're going to say it is equal to the absolute value of 1 minus 3. And 1 minus 3 is negative 2, but if you take the absolute value of negative 2, we get 2. And that is our distance. And we could simply look at this line right here and count upwards. Okay, here we go. 1, 2. It's a distance of 2. Let's do the next one. AC, well, that is equal to the absolute value of negative 2. That's where point A lies. Minus 3. So we get the absolute value of negative 5, which is equal to 5. There we have it, the lengths of BC and AC. Alright, a term called congruent segments are segments that have the same length. In this diagram that you see right here, PQ is equal to RS. So you can write this right here, that segment PQ is congruent to segment RS. And that's how it reads. And these little tick marks right here, that is how you're going to denote, or how you're going to look at the diagram and know that these segments are congruent to each other, is by looking at the tick marks and how many numbers there are. So let's say, for example, I have another 2 segments. Let's call this one XY and call this one QT. Okay, I'm going to say that this segment is congruent to this segment. So we can denote it just like that with a couple of tick marks. And that means the same thing. These 2 segments, XY and QT, are congruent to each other. Okay, here we have the definition of construction. First, it says you can make a sketch or measure and draw a segment, but these 2 things are not exact. You're not going to necessarily get the exact replica of one segment and another segment. If you want to draw the same segment and its exact length, a construction is a better way. So a construction is a way of creating a figure that is more precise. One way to make a geometric construction is to use your compass and straight edge. And that's what your book shows you. There's a step-by-step guide of how to construct congruent segments, and that is found on page 33 in your book. Here, this segment is the segment addition postulate. It is going to stay with you pretty much for the duration of geometry, so let's not forget this, okay? And we're going to be using it in proofs and everything from probably here on out. Not to scare you, but just to let you know, this is very important. What this states is, let's look at this down here. This whole postulate down here. It says if B is between A and C, so B right here is between A and C, then this segment right here, AB and BC, if we add those together, it is equal to the whole length of AC. And that is the segment addition postulate. So let's utilize it. So here we have G is between F and H. And then FG is equal to 6, FH is equal to 11. Find GH. Well, if we were to look at this in a drawing real quick, it says G is between F and H. And it says FG, that's 6, FH, that is this whole thing here, is 11. Well, by our segment addition postulate, this is what we would come up with. That FG plus GH is equal to FH. So let's plug in what we know and figure out what we don't know, which is what we're being asked for. What is GH? So plug in FG, that's 6. GH, that is what's in question. And FH, that is 11. Now if we subtract 6 from both sides, we're going to end up getting GH all by itself. And that ends up being 5. So GH is equal to 5. Here again, we're going to use that segment addition postulate to figure out first what is our x value. And then once we find our x value, we can find out what is our NO, our value of NO, which is this whole segment here. Okay, so using our segment addition postulate, let's state it using N, M, and O. It's going to be NM plus MO is equal to NO. Now let's plug in the values that we have in this diagram. NM, that is 17, and our MO, that is our 3x minus 5, and then our NO we are given is 5x plus 2. Now we have a linear equation to solve here. So here is what we're going to do. First, combine like terms. And that's going to give us, whenever we add together, well, subtract 17 minus 5, those are like terms, and 3x stays the same, so let's just keep 3x as is. 17 minus 5, that's 12, and it's a positive 12. And the other side, there are no like terms. Let's keep it like that. Now, subtract, we're going to get x, we're going to try to get x by itself, so let's subtract this 3x from both sides, and we get 12 equals a 2x plus 2. Now subtract the 2 from both sides, we end up getting a 10 is equal to 2x. Now divide both sides by 2, and we have x by itself, which equals 5. And that is what x is equal to. But don't stop here. Find what we are supposed to find in the first place, which is NO. Well, NO is equal to this up here, 17 plus 3x minus 5. So let's find that. 17 plus 3x, which is 5, minus 5 is equal to our NO. And when we add up, multiply, and everything, all of those numbers together, following the order of operations, hopefully, we get, we get 27. And that is what our NO is equal to. Alright, next we have the definition of midpoint and bisect. And they kind of go along with each other. So, the midpoint M of AB is the point that bisects or divides the segment into two congruent segments. So, for example, if M is the midpoint of AB, then AM equals MB. And here's a little example here. I'm going to draw it out for us. It says, here we have a segment AB that is equal to 6. And if our midpoint M is indeed our midpoint, it divides it. It divides that 6 in half. So AM is 3 and MB is also 3. And we're going to apply this right here in our next slide, our next example. Okay, so here we have again, well, D is our midpoint of EF. So we have measurements 4x plus 6 for ED and 7x minus 9 for DF. And if we know that D is indeed the midpoint, what we need to do is say, well, ED is equal to DF. And we can plug in our 4x plus 6 for our ED. And then our 7x plus 9, minus 9 for our DF. And we have an equation to solve. And our equation here, what we're going to do with this equation is similar to what we did on the previous equation. I'm going to subtract a 4x. Subtract the 4x from both sides. So we can get our x's all together and all by itself. We get 6 equals 3x minus 9. Now to get that 3x by itself, add a 9 to both sides, and we get 15 equals 3x. Now divide both sides by 3 to get that x all by itself, and we get 5. X is equal to 5, but it asks us to find what is ED, DF, and EF. And if we were to plug in that x equals 5, if we plugged in that 5 in for our x values here and here, you would see that our ED is equal to 4 times 5 plus 6, that's 26. And then our DF should be the same thing since we are dividing in half with that midpoint there. And it's 26. Now if we end up multiplying, not multiplying, but yeah, we can multiply 26 by 2. That's one way of getting EF. Or we can say 26 plus 26, that's equal to EF. And that is equal to, let's see, 52. And there we have it. All three things that we were asked to find right there. And that is all I have for you in this section, and we will be discussing the homework tomorrow. So see you in class. Bye.